Hi, welcome to Syneric Rocketry Systems. Let's analyze a little beta test. Rocket's attitude control responded quite good as it was able to recover the vehicle position from practically horizontal to perpendicular, but the PAD values were too strong and the overcorrection wasn't handled properly. Then the timing was slightly off and hit the ground early. However, the rocket was in perfect condition as the engine was able to eliminate a large percent of its speed. After some adjustments in the code and a small variation in the proportional term of the PAD as well as the system's rearming, the rocket was ready to perform another attempt in less than 15 minutes, proving its reusability and fast reflight capabilities. Now, let's take a look at the second attempt. In this test, the algorithm has had more time to operate the smoother control and hence a better outcome in general. The timing error between the flight simulation and the second attempt was 0.4 seconds, which means that the correct value will be probably 0.2 seconds apart from the simulation prediction. Which seems like it's a very small deviation, but as you can see, every instant counts. Limiting an engine has 2 seconds of bar. In other words, all the control has to be done in that time. This is certainly not ideal, but it is somehow achieved on attempt number 2. Moreover, the thrust curve is not the best on the market, but the non-availability of other engines like Estes or Aerotech left no other option. Nevertheless, the test gets close to obtaining a null vertical velocity as you can see here, while its attitude is controlled. In this other graph, we can see something like a hover in the altitude plot, but that is not the case. Due to the rapid deceleration of the vehicle, the barometric sensors captured an overpressure event, but that's all, certainly not a hover. The system is not flawless and has room for improvements. That's why it's a study we'll continue with the next mission, bachelor.